Students, let us continue that next problem. So in this problem, same, okay, compound pipes. Okay, we know that what is meant by compound pipe. There are different pipes of diameter, different lengths are connected in series from one tank to another tank. That is called a compound pipe. Okay, so last class we seen one problem. In that problem, they given different friction coefficient of friction value, different coefficient of friction value. Okay, so in this problem, they given same, okay, same friction value for all the three pipes. Here also they given three pipes. Okay, so let us once again I read the question. Three pipes of 400 mm, 200 mm, and 300 mm diameters have lengths of 400 meter, 200 meter, and 300 meter respectively. Full stop. They are connected in series to make a compound pipe. Okay, this line is very important to identify which problem this one. Okay, the ends of this compound pipes are connected with two tanks whose difference of water levels is 16 meter. If the coefficient of friction of this pipes is same and equal to 0.005, so the coefficient of friction value for all the three pipes is same, it is 0.005. Full stop. Determine the discharge through the compound pipe, neglecting first the minor losses and then including them. Okay. So what they asking? Discharge. And in two cases, neglecting minor losses and including minor losses. So let us see how to solve this problem. So first write the data given. Difference of water levels is H. Okay, it is 16 meter. It is the there are two tanks are there. That difference of water level of the surface. Next, length and dia of pipe 1. Length L1 400 meter and D1 400 mm. So if you convert it into meter means 0.4 meter. 400 divided by 1000, it is 0.4 meter. Length and dia of pipe 2. Okay, L2 is equal to 200 meter and D2 200 mm, which is equal to 0.2 meter. Length and dia of pipe 3. L3 is equal to 300 meter and D3 is equal to 300 mm, which is equal to 0.3 meter. Also, F1 is equal to F2 is equal to F3 is equal to 0.005. So this point is very important. So they given common friction factor. They given common friction factor for all the pipes. Okay, so this point is very much important point. Okay, so first case, first we neglect the minor losses. We have to include only major losses. Let us see. Let V1, V2 and V3 are the velocities in the first, second and third pipe respectively. Okay. From the continuity equation, we know the continuity equation A1 V1 equal to A2 V2 is equal to A3 V3. Okay, so now as we discussed in the earlier problem, as per this, there are three unknowns V1, V2, V3. So it is not possible to solve the three unknowns. So we have to convert all the terms into one unknown. Okay. So here, as per the continuity equation, first I taken this equation only. Okay, A1 V1 equal to A2 V2. So from this, find out V2. So V2 is equal to A1 V1 divided by A2. Okay, so which is equal to pi by 4 A1 pi by 4 D1 square, A2 pi by 4 D2 square into this V1. Okay, so this pi by 4 and this pi by 4 get cancelled. Okay, so therefore D1 square divided by D2 square into V1. Okay, which is equal to 0.4 divided by, so D1 is equal to 0.4 and D2. So here you can see the diameter D1 0.4 and D2 0.2. So 0.4 divided by 0.2 the whole square into this V1. Okay, so which is equal to 4V1. Okay, 4V1. So V2 is equal to, which is equal to V2. Okay, V2 is equal to 4V1. This is the first case. Okay, so we converted V2 in terms of V1. So next come to second equation. So this is A1 V1 and A3 V3. Take this two and V3. So we need only V3 means A1 V1 divided by A3. A1 V1 divided by A3. So for A1 pi by 4 into D1 square. A3 pi by 4 into D3 square into V1. Okay. So therefore pi by 4 and pi by 4 get cancelled. D1 square divided by D3 square into V1, which is equal to 0.4 divided by 0.2 the whole square into V1. Okay, so therefore V3 is equal to how much? So simplifying this one, sorry, some mistake is there. V3, sorry, D3 is 0.3. Here substituted 0.2. So please change this value is equal to 0.3, not 0.2. D2 only 0.2. D3 0.3. Here printing mistake. So 0.4 divided by 0.3. Okay, 0.4 divided by, so this is 0.3. The whole square V1. So finally 1.77 V1. So this is equal to V3. Okay. So this is the first step to find V2 and V3. So let us move to the next step. So now using the equation, we know if you neglect the minor losses, we have to write only major losses. So this is the equation we already know. H is equal to 4F1 L1 V1 square divided by 2GD plus 4F2 L2 V2 square divided by 2GD D2 plus 4F3 L3 V3 square divided by 2G D3. Okay. So substitute H is equal to 16. This is given in the question, and 4F1 L1 V1 square divided by 2G D1 and 4F2 L2 V2 square. So here for V2, so be careful, this V2 V3 we already converted in terms of V1. So V2 is equal to 4V1 and V3 is equal to 1.77 V1. Okay. So if you write the equation like this, means all the terms it is converted into in terms of V1. So V1 is the common term. Only one unknown value we have. Okay, instead of 3 unknown values, we converted into only one unknown value. Okay, so from this V1, which is equal to, we can simplify this equation. V1 we got 0.882 meter per second. So the velocity of the compound pipe 1, okay, pipe 1 is 0.882. So once you found the V1, that V2 and V3 are we can easily we can find. That is the next step. Okay. So what is our ultimate aim? To find the discharge. Okay. For discharge only V1 is enough. Otherwise you can calculate V2 and V3. You can substitute either A1 V1 or A2 V2 or A3 V3. Okay. See, all are same as per the continuity equation. Okay. So I have V1. So substitute Q is equal to discharge Q is equal to A1 into V1. So pi by 4 into diameter 0.4 the whole square into V1 0.882, which is equal to, finally we got the answer 0.1108. 0.1108 meter cube per second. Okay, so this is the answer. Okay, so now discharge through the compound pipe considering minor losses also. So now I am considering minor losses also. Okay, so minor losses at inlet, Now consider at inlet HI is equal to 0.5 V1 square divided by 2G. We know the formula. So there are 3 pipes. So I draw the diagram. So as per the previous problem only, there are 3 pipes. Okay, so at this is inlet and this is sudden contraction and here sudden expansion. So these 3 minor losses are we must include. Okay, so first at the inlet of the pipe, HI is equal to, we know the formula 0.5 V1 square divided by 2G. See, formula is important. Okay, next, between first pipe to second pipe, this is pipe number 1 and this is pipe number 2 and this is pipe number 3. Okay, so between first pipe to second pipe, HC is equal to 0.5 V2 square divided by 2G. Okay, so substitute the values. V2 we know already, it is 4 times of V1. So substitute the values and third one, between second pipe to third pipe, it is sudden enlargement. Sudden enlargement. So we know the sudden enlargement formula, V2 minus V3 the whole square divided by 2G. Substitute V2 is equal to 4 V1, V3 is equal to 1.77 V1 the whole square divided by 2G. Okay, so simplify the equation. We got each term in terms of V1. Next, at the outlet, this is the outlet. Okay, so inlet, sudden contraction, sudden expansion and outlet. So outlet formula H0 is equal to B3 square by 2G. So this is the formula. So substitute the values. B3 is equal to 1.77 V1 square divided by 2G, which is equal to this answer. So now we can calculate the velocity. Okay. So if don't put the same velocity in case of neglecting minor losses, we already found, because that velocity is different, this velocity is different. Why? Because here we are considering minor losses also. Okay, next, the major losses we already found. Okay, as in terms of 4F1 L1 V1 square, 4F2 L2 V2 square divided by 2G D, and 4F3 L3 V3 square divided by 2G D3. So as per this, we can calculate the equation in terms of V1. Next, summation of minor losses and major losses. Summation of minor losses and major losses. So these are all minor losses. These are all minor losses. And this is major loss. Major loss is common. We calculated. Otherwise, you can write in the formula. So finally, summation of major losses and minor losses, H is equal to, this is H is equal to this value. So H is 16 meters, substitute the value and find out velocity. Find out velocity. So once you find out the velocity, discharge Q is equal to A1 V1, which is equal to pi by 4 into 0.4 square into 0.864. 0.864 is the velocity V1. Okay, so finally we got the discharge 0.1085 meter cube per second. 0.1085 meter cube per second. This is the answer. Now we will compare the velocity and the discharge in case of previous case and this case. So first we will compare the discharge. What is the first case velocity? 0.882. So now here 0.864. So velocity is decreased while considering minor losses. And also you can see the discharge 0.1108 meter cube per second in previous case. If you are considering minor loss, it is 0.1085. It is reduced. Okay, so always if you consider minor losses means compared to not considering minor losses, the discharge will be lower and velocity will be lower. Okay, so from this two problems we can prove that one. Okay, students. So up to this compound pipes are over. Pipes in series is over. So next thing we will see the equivalent pipe. Okay, what is meant by equivalent pipe? So students, next chapter equivalent pipe. What is meant by equivalent pipe? So let us see, I will tell one example. Based on that you can easily understand. Suppose a beam is there, a simply supported beam is there. A number of point loads are acting, different loading. So 10 kilonewton, 20, 15, 12, 18, like that. Around 10 loads are acting or 5 loads are acting. Okay. So I want to convert this all the loads into one load. What is that load called? It is called resultant load. Resultant load. So if you, so same impact will be happen in the beam. Okay, if you convert a number of loads into one load, that load is called resultant load. Okay, so same way in case of pipes in series, pipes in parallel. Okay, sorry, pipes in series or compound pipe, there are number of pipe diameters are there under different lengths. Okay, I want to convert the number of the pipes diameter, number of pipes, lot of different cross section, different length. I want to convert it into one diameter for the same resultant, same discharge, same head of water. So that pipe is called equivalent pipe. Okay, as I told earlier, resultant load same like it is called a resultant pipe. So please be remember. Okay, so the number of pipes is converted into a single pipe for the same output. It is called equivalent pipe. So now we will see the definition. An equivalent pipe is defined as the pipe of uniform diameter. So this point is very important. Uniform diameter. So in previous case, that means pipes in series or compound pipe, there are different diameters we used. But here only one diameter, uniform diameter. Having loss of head and discharge is equal to the loss of head and discharge of a compound pipe consisting of several pipes of different lengths and diameter. Simple. Okay. So same loss of head and same discharge, same output. Okay. So we converted number of diameter pipes into one diameter. So that is called uniform diameter. The uniform diameter of the equivalent pipe is known as equivalent diameter of the series or compound pipe. Okay. So finally, L divided by d power 5, length divided by d power 5, which is equal to L1 divided by d1 power 5 plus L2 divided by d2 power 5 plus L3 divided by d3 power 5. It is going on. So this length and diameter is the equivalent pipe. So this term, okay. So this term you can see here, left side of the equation, this term is for equivalent pipe and these terms are the compound pipes. Suppose 10 pipes are there. So you have to increase L1, L2, L3, L4, L5, L6, L7, L8, L9, L10. So same way, D1 power 5, D2 power 5, D3 power 5, D4 power 5, like that. Okay. Suppose only 3 pipes are there. You can stop here up to this. You can stop up to here. 4 pipes is there means L additional one term we have to add. L4 divided by D4 power 5. Okay. So this above equation is called Dupuit's equation. So this equation developed by the scientist Dupuit. So this is called Dupuit's equation. So derivation is not important. The problem is very much important. Okay. So I think all of you understand what is meant by pipes in series, compound pipe and equivalent pipe. What is the difference between pipes in series and equivalent pipe? Okay. So now we will see one problem in this equivalent pipe. Okay. So 3 pipes, there are 3 pipes are there, 800 meter, 500 meter and 400 meter, and of diameters 500 mm, 400 mm, 300 mm. So previous one is length of the pipe, and this one is diameter. Okay, so 3 pipes length they given, and also 3 pipes diameter also given, are connected in series. So these pipes are connected in series. So these pipes are to be replaced. So please understand, these pipes are to be replaced by a single pipe of length 1700 meter. So you can see here total length. So 800 plus 500 plus 400, which is equal to 1700 meter. That is the total. Suppose in the examination total length is not given, means you add this 3 lengths. Sometimes they will not give the total length of the pipe. Total length is nothing but the summation of individual pipe length. Okay, so what they asking, find the diameter of the single pipe. So single pipe means that equivalent pipe. Okay, so now length of pipe 1 800, L1 is equal to 800 meter, and diameter D1 is equal to 0.5 meter. Next, length of pipe L2 is equal to 500 meter, and D2 is equal to 0.4 meter. Okay, next, length of pipe 3, L3 is equal to 400 meter, and D3 is equal to 0.3 meter. Okay, next, length of single pipe, which is equal to the summation of 800, 500 and 400. Okay, so now applying the equation. So we know the Dupuit's equation for the equivalent pipe. What is that Dupuit's equation? L divided by D power 5 equal to L1. Here only 3 pipes. Okay, we have to write up to the L3 is enough. So L divided by D power 5, which is equal to L1 divided by D1 power 5 plus L2 divided by D2 power 5 plus L3 divided by D3 power 5. So what is L1? Sorry, L is the length of single pipe, 1700 meter divided by D power 5. And L1 is 0.5 meter. Okay, 0.5 meter. Or sorry, L1 is 800 meter and D1 is 0.5 meter. So L means length, D means diameter. Okay. So this D is the unknown value. This only they asking what is the find the diameter. So L1 we know 800 meter and D1 is 0.5. So substitute all the values in terms of meter. That is the convenient for us. Next, plus L2 is 500 meter and diameter 0.4 meter. And L3 400 meter and D3 0.3 meter. Okay. So you have to convert power 5. We know about square cube. So this is power 5. So in calculator, the option is there, x power y term. Okay. So you can use this term and find out the value. So first, how to simplify this one means, first simplify these 3 terms. Okay. So for the first term, it is 25,600. Second term, 48,828. Third term, 1,64,609. So finally, we got an answer 2,39,037. Okay, this is the value. So we need D power 5 only. So equate this one into this equation. Here only one unknown is there, D power 5. So D power 5 divided by 1,700. So D power 5 goes to this side, means this 2,39,037 goes to denominator. So 1,700 divided by 2,39,037. So finally we got D power 5, which is equal to 0.007118. This is the answer. So from this diameter, D is equal to, what is the answer? 0.3718. Okay, 0.3718. Okay, so this D power 5 comes to this side, means power 0.2. So which is Answer is 0.3718. So this is in terms of meter. They given in terms of meter. So always diameter is, we can tell in terms of mm, not in meter. Okay, in terms of mm only we have to tell. So using this equation, and we can find 371.8 mm. Okay, so this is the diameter of the equivalent pipe. So initially that compound pipe having different diameter, that is 500 mm, 400 mm, 300 mm. It is replaced by a single pipe. That diameter is this is the resultant 371.8 mm. So we have to provide that 371.8 mm for the same discharge. So this is the simple problem. So this type of problem they may ask in 5 mark questions. Okay, they never ask 10 mark. This is the 5 mark question. Okay. So next video we will see the next chapter, that is called parallel pipes. Okay.